Okay, welcome back. We are going to dive into 8.4 factoring using GCF. Now, GCF means greatest common factor. So, we just want to kind of spell that out, greatest common factor. Okay. Now, there's a few different types of ways that we're going to learn how to factor, and factoring out GCF, or greatest common factor, is the first one we're going to deal with. Now, factor, okay, what does the word factor mean? Okay, the word factor means um, two numbers, two numbers or terms that multiply together. Okay, so if I said 2 times 2, okay, equals 4, right? We know that 2 times 2 equals 4, right? 2 times 2 is a factor of 4, okay? Or you could say 2 times x equals 2x, right? 2 and x are factors of 2x, okay? So this whole idea of factoring is kind of undoing what we dealt with the first 3 sections of this chapter, which was multiplying, or sorry, last section was 8.3, multiplying polynomials. Now let's kind of dive back into what we talked about. Excuse me. Last section was that if I have 3 times the quantity x minus 1, how do I undo the parentheses? Well, one, I told you you could use the box method. So I have a 1 by a 2. So a monomial times a binomial, I need a 1 by 2 box. Okay, put my 3 out here, put my x up here, put my negative 4 up here. Okay, find the area of each box. So 3 times x is 3x. And then I have 3 times negative 4, which is negative 12. So when I multiply that out, okay, I had 3x minus 12. And that was my answer, okay? Now, the idea of factoring, let me highlight that. Here we go, factoring, okay? The whole idea about factoring is to start, okay, start with the expanded form, 3x minus 12, and go backwards to 3 times the quantity x minus 4. So it's kind of a reversal of what we were doing. So we have the expanded form. Now I want to go back to, this would be called factored form, okay? And then this would be called expanded form. All right, so let's try a couple examples. Now, the activity that I had you guys do prior to this section was to discuss different types of factors. So factors are numbers that multiply together to give you the number you're looking for. So when I'm dealing with, let's look at example 1, right? When I'm dealing with, here I'm dealing with a binomial, okay? I want to see what number or variable both of these two terms have in common. Okay, what can you multiply that number by, okay, for both of those terms? So if I have a 2, let's just worry about the numbers first. What can I multiply something by to get a 2 as well as a 6? Okay, multiply a 2 by as well as a 6. Well, what are the factors of 2? So if you remember your factor trees, I have, well, how can I multiply to get a 2? I have 1 times 2, right? I know that. So right here, my greatest common factor, okay, would be 2. Let's look at 6, or a negative 6. Well, you could just talk about 6, then go back to negative 6. Okay, so I have my factor tree. Well, I know 1 times 6, right? I know 2 times 3, right? I think those are, pretty much the only factors of of 6. You know, 3 times 2 is the same thing as 2 times 3. 6 times 1 is the same thing as 1 times 6. So now what is the greatest number that they have in common? It's that 2 right there and that 2 right there. Okay, so I know that I could pull out a 2 from this expression. Okay, so what does that mean? So essentially, I'm gonna kind of show you my way of ending up with my parentheses, and then we could talk about a separate way. So for here, I want to see, okay, what can I multiply 2 by to get a 2x, and what can I multiply -6 by, or 2 by to get a -6? I could think of it like that, or I could take that 2 and just divide it. Um, divide 2x by 2 and divide -6 by 2. Okay? Now, that was my number that I pulled out. Now, let's look at the variables here. Okay? I have an x here and then I have no x here. Now, if I only have one of my terms that have an x, then I can't pull out an x from both terms. I could only pull it out from one term, which means that they don't have something in common. Okay, so in this case, 2 is my only greatest common factor. Okay, good. So now I'm going to just simply divide down. Okay, now I'm going to divide down. That's what's going to end up in my parentheses. So go back. I want to end up with this form. Okay, so you can start seeing it coming about. So now I'm just going to divide down. So 2 divided by 2 is, okay, 1. Okay, and then I'm left with x. Good. Now I have -6 divided by 2 is -3. Okay, good. Now that's what I'm left with in the parentheses. Now what did I pull out? Okay, what did I pull out? I pulled out my greatest common factor of 2, so you're just going to attach it on the outside. So that is going to be my answer. Now, if you could always check to see if your answer is going to be correct, or by doing the opposite of what you just did. So if I factored, I could always multiply it out, and I should get what I started with. So 2 times x is 2x, 2 times -3 is -6. So if I multiplied it out, I would get that. Okay, so I'm good there. Good. Example 2 is going to be a money problem. Let's skip to example 3. Okay, so let's start with the numbers like I did earlier. Okay, so right here I have a 2 and I have a 10. So thinking about the factors of 2, like I said, all I have is 1 times 2, right? Over here, let's talk about 10. Now I'm just going to go straight down. I'm going to always start with 1. 1 times what is 10? 1 times 10. Let's talk about 2 times what? 5 is 10. 3 times nothing. 4 times nothing. Then 5 times 2. So these are going to be my only factors, okay, of 10. So here, my greatest common factor between both of these are 2 and 2. So I know I could go ahead and pull out at least a 2. Okay, now, if I have p squared here in p, how many p's do they have in common? Well, what does p squared actually mean? P squared actually means, what are the factors of p squared? That actually means p times p, okay? Then I have p, just regular p right there, so what can I multiply? What 2 things can I multiply by to get p? You know, if I just have a p and I multiply by 1, it's itself, which is p. So how many p's do they have in common? They have at least 1p. Okay? So I am going to pull out that 1p, and that is going to be my greatest common factor. It's 2p. Not just 2, not just p, you have 2p. Good. Now that I figured out my GCF, okay, I'm going to go ahead and divide down and see what happens, see what is a result into my set of parentheses. So I have 2 divided by 2, which is 1. Now if you remember our exponent rules, if I have p squared divided by p to the first, division of like base exponents, we are going to subtract 2 by 1, which is 1, so I'm just left with p to the first power. Okay, Good. Next one, I'm going to have positive 10 divided by 2 is 5. P divided by P is just 1, so I don't even need to write it. Okay, so now I'm left with what's in my parentheses. Okay, good. Now what do I have to attach on the outside? On the outside, I'm going to be left with 2P. So just like I talked about before, you could always check your answers by multiplying it back out, and you should get 2P squared plus 10P. So if I have 2P times P, that would give me 2P squared. 2P times 5 is 10P, so I'm good right there. Alright, so you have example 2 and 4 as money problems. Good luck. And let me check when you're done. Okay, so let's look at example 5. Now, example 5 is a little bit different. Why? I have 1, 2, 3 terms. Okay, it's really not too much different, but all I need to have is something in common in all 3 terms. So let's talk about the numbers. I have a 3, I have a negative 3, and I have a positive 9. Don't worry about the signs too much, just worry about the coefficients, which is 3, 3, and 9. So over to the right, I have my 3, I have my 3, and I have my 9. Factors of 3, 1 times 3 is 3. Same thing, obviously, 1 times 3 is 3. Okay, for 9, I have 1 times 9, and then I have 2 times anything? No. 3 times 3. Alright, 4 times anything, 5 times anything, 6 times anything, 7 times anything, 8 times anything, and then you're back to 9. So that is all that's all the factors for 9. So what is the greatest common factor? 3, 3, and 3. Okay, so 3 is going to be my number I'm going to pull out. Good. Now, let's talk about our variables. Here I have g squared. For my middle term, I have g. Here I don't have a g. Now, if I'm looking at all 3 terms, the only way you could pick out a variable, take out a variable, is if each term has a variable. So if 9 doesn't have a g attached to it, can I pull a g from it? No. So I can't pull out any g's because that 9 does not have a g. So my greatest common factor is actually just 3. So let's go ahead and divide down. When I divide down, I have 3 divided by 3 is 1, and I'm left with g squared. Okay, negative 3, always carry the sign. Negative 3 divided by 3 is negative 1g. Okay, then I have positive 9 divided by 3 is positive 3. Okay, and I'm left with on the outside my GCF, which is 3. So this would be my answer. So just like I said, if you multiply it back out, it should give you 3 squared minus 3g plus 9. 3 times g squared is 3g squared. Cool. 3 times negative 1g is negative 3g. Awesome. 3 times 3 is positive 9. So I am A-okay. Okay. So now there's a couple of hints that you could kind of think about when you are factoring out a GCF. Now, one I already told you, you can't pull out a variable if all terms don't have a variable. Okay? Then with the coefficient and the number you're going to pull out, you can't pick out a number that's higher than the lowest coefficient. So if I have a 3, and a 9, I can't pull anything more than a 3, right? Okay, going back, okay, I have a 2 and a 6. I can't pull anything more than a 2, okay? For 2p squared plus 10p, I can't pull anything more than a 2, right? Okay, so go ahead and think about that. That is going to be those are my hints for today's lesson, and example 6 is a money problem. Good luck, and I'll see you next time.